The first video for this week is the completion of the lesson 4.6 guided notes. I do have 3 videos this week, but I expect that they should, at least the first 2 should be relatively short. The third, I'll try to keep it not too long for you, and if I need to, extend it until the next week. But this is from the lesson 4.6 notes, which I posted again during this week's module. So you do have it available. We're going to begin with question number 24 from those guided notes. It asks us in these problems to replace each blank with less than, greater than, or equal to make a true statement. You may use a calculator for these problems. So hopefully you have one handy, or at least can use your cell phone calculator or your computer to calculate these. So number 24, we're comparing the square root of 34 to 5 3/8. So the square root of 34, which I plugged into my calculator, got me about 5.83. And I did include 2 decimal places after the decimal point, just to make sure that I had enough to be able to compare the two. 5 3/8, what I would do is do 3 divided by 8, which gets you 0.375. So 5 3/8 is 5.375. So it's pretty easy to compare these two. 5.8 is definitely greater than 5.3, so this would be greater than. Number 25, the square root of 125 I did in my calculator and got about 11.18. 11 7/8, what I did was 7 divided by 8 to get 0.875, although I actually have the eighths memorized, so that makes life a little bit easier. But 7/8 is 0.875, so this will be 11.875, which means that the square root of 125 is less than, ooh, don't move all of that, is less than 11 7/8. Number 26, 3.2 is already a decimal, so I did the square root of 9.5 in my calculator to get about 3.08. 3.2 is greater than 3.08. So once you change them, once you change them both to decimals, it's pretty easy to compare them. Number 27, the square root of 3, I plugged into my calculator to get about 1.73. 1.5 is definitely 1.5. So 1.73 is greater than 1.5, or 1.5. Number 28, I calculated the square root of 7.84 to be about 2.8. And then comparing that to it was exactly 2.8. Comparing that to 2.8 here on the right-hand side means that those two are equal to each other. Kind of forget I had plugged this in or typed these in a couple of days ago. So square root of 7.84 is exactly 2.8. So those two are equal. Now, if this was 2.8165, it would not be equal. So we would just want to be very careful there. Last one of these, number 29, square root of 12, and I plug it into my calculator, is going to get me about, keep moving that, I apologize, give me about 3.46. So 3.67 is going to be, once again, greater than the square root of 12. These are ones, of course, you could certainly try on your own. With calculators, this is just giving us a chance to practice comparing decimals, but also just plugging these things into our calculator as well. All right, let's take a look at the next group of problems, because these ask us to do them without using a calculator. So it says, order each set of numbers from least to greatest. You may not use a calculator for these problems. So the square root of 49, hopefully you recognize that as 7. So I just wrote all of these, or typed all of these up. Square root of 49 is 7. 6.91 repeating, I kept as a decimal. I think it's easiest if we write them as decimals to compare. And then the next one, 7 1/8. Again, I have the eighths memorized, so it makes life pretty easy for me. If you don't, you might need to do 1 divided by 8. 1 is underneath the division symbol, 8 is outside. That's going to get us 0.125, and of course then that will be 7.125. So in comparing these at this point, 6.91 repeating is the smallest, then 7, or square root of 49, then 7.125, or 7 1/8. The last one, 15 over 2, I wrote as a mixed number. That would be 7.5, which is 7.5. So let's put all that together then in order from least to greatest. So the smallest is clearly the 6.91 repeating. Next is 7, which was, I wrote it as it originally was in the problem, which is square root of 49. Next would be your 7.125, which is 7 1/8. And then the largest is our 7.5, which is 15 over 2. All right, let's give number 31 a try. 4 1/3, hopefully you have this memorized. Again, there's some decimals you really should memorize, some fraction decimal conversions. That's 4.3 repeating. Now the square root of 43, I don't know what that is, but I know that it's between 6 and 7, since 43 is not a perfect square. The perfect squares it's between are 36 and 49. Square root of 36 is 6, square root of 49 is 7. So I know it's between 6 and 7. I designed this so you can answer the question without having to, without necessarily having to know what the square root of 43 is. Up next, we have 4.13. Somehow I skipped 12 over 3, I think. So I'm going to have to add that in. My apologies. Sometimes I make some mistakes, and I just recognize that here. But I'm missing 12 over 3. Let me do that. 4.13 I'm going to leave as it is. Let me add this in, so bear with me. Silly mistakes. So we've got 12 over 3, which we know equals 4. So I am going to have to add this in then. To my answer, because I do not think I typed it in as part of that. But 12 thirds is equal to 4 exactly. And then the cube root of 27, I do have, that's 3, since 3 to the third power is 27. So when I go to list these in order from least to greatest, my smallest number is going to be the cube root of 27, because obviously that is 3. But I do need to add in, and I'm going to do that here. So up next, instead of putting 4.13 next, which it will go after 12 over 3, this 12 thirds, let me copy that and see what we do as teachers all the time. So bear with me while I get this guy moved. Let's see if I can move it. All right, so move you down there. My apologies for messing this problem up, but we can fix it, no big deal. So my smallest again is the cube root of 27, which is 3. Up next would be the number 4, which is 12 thirds. Then we would have 4.13, followed by 4 1/3. They are not equal to each other because, again, 4 1/3 is 4.3 repeating. And then clearly the square root of 43 is going to be the largest since it's between 6 and 7. So again, cube root of 27, 12 thirds, which I neglected, 4.13, 4 1/3, and the square root of 43. All right, number 32. Negatives. Let's compare these. So -2 is -2. -1.5 is -1.5. -1 8/10 is pretty easy. That's -1.8. It's also the same as -1 4/5. It's just not reduced, but it's -1.8. And then the negative square root of 6. Now, I don't know exactly what it is, but I know that while 6 is not a perfect square, it's between the perfect squares of 4 and 9, meaning the square root of 6 is between 2 and 3. So I know that this is going to be between -2 and -3. So when I go to put these in order from least to greatest, the negative square root of 6 is going to be the smallest since it's going to be beyond -2. Picture a number line, or imagine a number line if needed, followed by -2, then -1.8, which is -1 8/10, and then your largest is -1.5. Remember with the negatives, it's the opposite order of what we would think. And I'm going to try to avoid putting too many negatives on your practice because I know they're kind of tough. If we were in the classroom, we'd probably see a bit more of this, but I realize we're also not in a classroom setting. All right, let's take a look at the last one of these, number 33. We've got the cube root of 8. Hopefully you remember that is 2, since 2 to the third power is 8. 3.3, of course, is equal to 3.3. 12 thirds, I did not forget about it here, is 4. Had I known or remembered that it was on the next slide, I would have just copied it over. And then finally, we have 3 1/3. We already talked about 1/3. That's 0.3 repeating, so that's 3.3 repeating. So from least to greatest, 2 is the smallest, so that's going to be the cube root of 8, followed by 3.3. 3.3 repeating is slightly bigger than that since 3.3 is like 3.30, and 3 1/3 is 3.33. So 3 1/3 comes next. Finally, our largest is 12/3, which is of course equivalent to 4. All right, so we've got a few more questions to look at. Let's go through these a little quicker. Number 34, it says, Sid says that the answer to negative square root of 25 does not exist, while Pete says that the answer is negative 5. Who is correct? Explain. What do you think? All right, hopefully you recognize that Pete is correct in this case. A negative number can be outside of the square root, but if the negative is inside the square root, then it does not exist. So Sid would be correct if this said the square root of negative 25. That does not exist, but the negative square root of 25 does. Number 35, Grant says that the cube root of negative 1 does not exist, while Brinley says that the answer is negative 1. Who is correct? Explain. What do you think? So if this were a square root, Grant would be correct, but you are looking for the number that when you cube it, you get negative 1. This number is negative 1, so Brinley is correct. If I take negative 1 to the third power, I get negative 1. So I'm allowed to take the cube root of a negative number, just not the square root of a negative number. Finally, number 36, which point on the number line best represents the square root of 84? What do you think? So 84 is not a perfect square, but it is between 81, which is a perfect square, and 100. The square root of 81 is 9. The square root of 100 is 10. So I know this is between 9 and 10. But 84 is pretty close to 81. So I know that it should actually be pretty close to 9. The closest point that is close to 9 but is above 9 and between 9 and 10 would be point C. So what I said here was the square root of 84 is a little more than 9 since 9 squared is 81. So it makes the most sense that C would represent this value. Now, this video went a little longer than I expected, basically because I made that mistake on the one problem, but you get the idea. There is a second video that I want you to watch on solving some equations with square and cube roots before you try assignment 1, but I will put some questions from this video on assignment 1 for you to try. Not a lot, and I'll try to make them as easy as possible given that we're not in the classroom, but I will give you some practice again that goes with assignment 1. Thanks for listening.